This conference will now be recorded.
And today we are going to see some more examples. It is initially the problem will be given in two ways, and we can represent. We can draw that encoder, convolutional encoder based on that. And one method is that we have seen in the last class, that is the encoder for a rate. It will be given, for example, rate 1 by 2 and constraint length k is equal to 3. In that way, it will be given the convolutional encoder with the rate 1 by 2. Here it means that k by n, that is small letter k, and n, that is number of outputs corresponding to the message. Here n represents the total number of outputs corresponding to each k number of message bits, and capital K constraint length, we have seen that, and it will be also given as you can see in question paper. Those who have gone through the question paper I have shared, you can see that, or in the textbook it can be seen like this: a 212 convolutional encoder. 212, it will be given like this. This here it means 2 is the n value here, first 2 n, and 1 here represent that k, small letter k, that is the number of messages, and this 2, that the number of shift register, two shift register stages. That is here we can represent the convolutional encoder in two ways. That is one is we can make use of one shift memory element for accommodating that present input, or without using a memory element to accommodate that present input. For here it means that is that number of stages in the shift register, this two is here, these two are same, that is rate 1 by 2 and capital K constraint length 3, or it will be given as 212. This I will represent these two representation. It is here three memory elements. We can represent as M, M1, M2, and input is coming here, and a particular example in this first input here, here two outputs, therefore two adder elements will be there, and depending on that connection you can provide the connection here. It is the one representation, that is at the output. That output can be represented as V1, it is V2, and a switch here for selecting these outputs from this, that is switch position to either 1 or 2, that is it comes alternatively initially to that position 1 and position 2 then, and here we can say it is the output V, that output, and here input and represent as U. Okay, that is one representation, that is here we are using three memory elements, and another we can represent, it is with two memory elements. That representation can be done like this. Here the input, that is we can take it as U. Then here two memory elements, two outputs, therefore two adder elements, and connection to that is like this. And the second output, we can take it as here the input, present input M can represent as M1, M2, and from this memory adder elements, the outputs here, two switches, two positions in this output switch. Here the output V1 and here the output V2, and here the switch alternatively connected to position 1 or and 2, for initially to 1, then 2, then again to 1 and 2. Therefore corresponding to each input message M, it generate the output. Here the output V. Okay, that is here that V1, we have that V1 equal to M XOR M1 XOR M2, and V2 equal to M XOR M2. That is a two representation here. You must note that that is here that dimension of the convolutional encoder can be given in two ways. That is a rate, the convolutional encoder with a rate 1/2 k, constraint length 3. It will be this, and also it will be given as 212. That is here it represent that small letter n, here small letter k, and this 2, that is these stages, memory elements, the number of stages in the shift register here, M1 M2, two stages. For here we can see one that present input, it is taken outside. Therefore here we will have to represent the encoder in this way. Okay, in question paper it will be sometime it will be seen like this, the convolutional encoder with it, convolutional 212 encoder. Okay, if it is 313 means three outputs, therefore there will be three adder elements, and here V1 V2 and V3 here, and 1, k is equal to 1, here only one message which is taken at a time, and 3, therefore M1 M2 M3, one more element you will have to represent here. That is about this dimension of the code. Those who have gone through the any of the question paper or the textbook, you can see like this, the dimension is given as 212. Okay, here small letter n, here it is small letter n. How many outputs are there? Then here it is small letter k, and it is the number of stages in this shift register. Here M1 to 2 here, and outside this that present input is taken, M is taken outside. Therefore M1 M2. If it is 3, then we will have to take this like M1 M2 M3. Okay, hope that you have got that convention used, and it is sometimes it is termed as small letter m, nkm. Sometimes not, sometimes it is it means this nkm. It is rate 1/2, that is k by n and capital K. Sometimes it is given as L, capital L, and here it is nkm. This small letter m represent the number of stages in the shift register, number of stages in the shift register. Okay, hope that you got that convention used to give the to give the dimension of the code. Okay, please respond through the chat box, yes or no. Have got that convention used, rate and constraint length, or nkm, small letter n, small letter k, and m. This m indicates the number of stages in the shift register. All of you, please respond through the chat box. Yes or no? Okay. Okay. Go through the question papers. You can see such questions. Next, that is, we have seen the Viterbi algorithm in the previous class. Viterbi algorithm. It is the decoding of the convolutional encoder, and I will explain once more that so that we can decode a particular message, received message. I will take one example. Okay, the same example can be taken. That is a 212 convolutional encoder. 212 212 convolutional encoder, and that previously represented a convolutional encoder. That is this particular convolutional encoder, and here we have that v1 is equal to m plus m1 plus m2, and v2 is equal to m plus m2. Okay, then for the convolutional Viterbi algorithm, we are making use of that trellis diagram. And here that trellis diagram, here it is. You know how to draw the trellis diagram. Here here the states are A, B, C, D. What you know what is meant by the states of the convolutional encoder, and the outputs. Here the solid line represent the input bit is 0, and we write the right along that the output bits. Here two output bits. Here it is 1, and here it is 1 0, and here from B to D 0 1. From C to A it is 1 1. C to B it is 0 0, and D to C it is 0 1. D to D, the output bits are 1 0. That is, this 1 0 means when the state is D and the input bit is 1, next state will be D, and the two output bits are 1 0. And we can decode a particular sequence of message. Okay, the received sequence, here it is 0 1 1 0 1 1 0 1 0 1 1 0 1 0 1 1 1. I am explaining this again because of its importance, exam point of view. And here the first step is definitely the first stage will be A. Therefore, we start with that stage A and represent it as A0. You take this convention A0, and then two chances are input bit is either 0 or 1. With input bit 1, next state will be A, represent as A1, and with 1 as the input bit, next stage will be, from this diagram we can see B, therefore represent as B1, and write the output bits along each possibilities. That is, here it is 0 0, here it is 1 1. Okay, it is written from the trellis diagram. Next is, we will have to take the first two bits from the received sequence. Here we have 0 1 is the first two bits of the received sequence. We will have to decode that. Then method is, we find the number of bit position in which these two bits and the output bits along each branch is different. For here, first bit is same, second bit is different. Here 0, here it is 0, here it is 1, here it is 0. 0. Therefore, one bit it is different. Therefore, metric associated with this branch is 1. Similarly, for the second branch, here 1, the received sequence bit is 0. Therefore, it is different. Second bit is 1 here, 1 here. Therefore, in one bit position, it is different. Therefore, we write the branch metric near to that output bits. Okay, next is, we will have to write the total path metric up to this. It is written along that node in circle. Here only one branch from starting from this first stage A0, for we can write here it is 1. It is written in circle, and here also it is 1. It is written in a circle uh, at that node. Then next is, the present state is A1 or B1. Therefore, next state can be here A. There are four possibilities. Okay, therefore here A0 is written first state, the starting stage. Then next stage we have represented A1 and B1. Next here write A2, B2 like that. Therefore here write as A2. Here write as B2. Here C2, D2. In this stage, all the states take it as 2. Write 2 as a suffix. Next stage we will write A3, B3, C3, D3 like that. The advantage is that finally we can write the we will have to identify the survived path. We can write the survived path like this: A0, A1, B2, C3, D4 like that. Then it is easy to understand. Easily identify that particular path if we use this convention for writing that node representation. Okay, anyway, A2, B2, C2, D2. Then that is here, copy that trellis diagram here. Here it is 0 0. The path output bits are 1 1 here along the path A B. Here B to C it is 1 0. B to D it is B to D it is 0 1. Then next step is, for the convolution Viterbi algorithm decoding, take the next two bits. Here it is 1 0 1 0, right at the top of that stage. Then find the metric associated with each branch. Okay, here first bit is different, second bit is same. Therefore, branch metric here it is 1. That is A1 to A2. Along this branch A1 A2 branch metric is 1. Means how many bit position it is different. Then here 1 1 and it is 1 0 here. Therefore, first bit is same, second bit is different. Therefore, 1 is the branch metric. Then here 1 0, here 1 0, here also that actual received input, received output bits are 1 0. Therefore, branch metric associated is, that is along this branch B1 C2 is 0. Then 0 1. First bit here 0, here it is 1. Second bit here it is 0, here it is 1. Therefore, both bits are different. Therefore, branch metric associated along that branch is 2. Okay. Next is, you will have to write the path metric. Here 1 up to this, starting from the initial stage A0 up to this 1, then that 1 plus 1 2 here. For it in circle, that path metric, that is path metric of the path A0 A1 A2 is 2 here. Then another path arriving at B2 is A0 A1 B2. Here the path metric is 1 plus 1 2, right in the circle along that. Then 1 0, therefore 1 plus 0 see 1. Then here 1 plus 2, here path metric is 3 here. Okay. Then in the next stage, we have to represent the complete list. All the possibilities are there. Here represent uh, nodes A, B, B3, B3, T3. Okay. Then from C to D, C2 B3 another path, then 3. Here write the output bits. Here it is 0 0 1 1. Then from B2 C3, here it is 0 from B2 D3, it is 0 1. Then B2 1 3, it is uh, C one B 0 0 D2 C3, it is 0 1. D2 D3, it is 1. Then here it is 1 2 on top of that particular state. Take that 2 bits, then find the branch metric. Branch, there are stages with right, the one here one is 1, second here also it is. Then from B to C3 it is, then 0 1 here, here 1 0, here it is 2. Then C2 3 0 1 0 0 here, C2 B3. Therefore here is 0 geometry here metric, then 0 1 here, branch is 2. First bit is different, second bit different. For branch metric is 2. Then 2. Here also for branch metric is 0. We know three are each node here, that is A3, B3 arriving. Therefore, there will be 2 path metric associated with this node. Then top is below. One path is arriving at the top and one is for write the 2 path metric associated with the node near one. It is in circle. That is here up to this 2. Then 2 plus 1 is 3. The top path, you have to write that here 1 plus 1 here 1 plus 1 here 2 here then 3 plus 2 here it is 5. Then at D3 2 plus 2 4 0 3 is at each node plus 2 are arriving, that is starting paths are arriving each node. Then here we continue with one path we avoid the another one which is having higher metric. We take cross mark on that path, that is we have not considered we are not considering this particular path, that is A0, A1, A2, A3 further. We maintain only, we continue with the one C2 A3 path we are continuing with. Then here 3 2, therefore that higher metric is 3. Put a cross mark on that, that is we are in that particular path. Here 2 5 moving, avoiding, therefore move that one. Then here 4 5 4 and 3, therefore we put a cross mark on that particular path which is removing. We continue with the other branch on maintain paths from this. Then again we like to represent these. That is here. Okay, for represent like this. A sorry, for C from D. Then write all the to C and D C to D. Output 0 0 1 1. And here it is 1 0 1. Then along this branch 1. Here it is from D to C is 0 0. Then from D to C4 it is 0 1. D to D0 along that branch. That is the complete trail list diagram. We will have to take the next 2 bits represent that. Here it is 1 1 metric associated with these 8 branches. Therefore here it is here 0. Here also it is 0 0 0. Here 1. Here it is 1. For it is 2 here. Here it is 1. Here it is 1. Here it is 1. These are the metric total path metric. Here up to this, here we have cancelled this 3 path with the path metric 3. Therefore 2 here. 2 plus 4 for the above path. Then over path 5 we have already lower. Here it is 2 5 2 plus 0, therefore it is here. Then here for here 2 the it is 4. It is 2. Then here it is 1 3 here. Then the lower here it is 3 plus 1 4 here. Here it is 2 plus 0 2 here. Then here that way path metric associated with each path. Then we cancel the path which is having the higher metric. Therefore, this put a cross mark on this above path. That is, it is 4 and 2. We continue with this with the path with the metric 2. Then 2 and 4. Therefore, the lower path is cancelled. 3, 4 lower path is cancelled. 3 and 4 maintain. We continue with the path which is having the metric 3. Then here 2 and 4. Therefore, remove that. Then I will represent one more stage. Hope that you are doing with me parallelly. It is simple. Once it is understood, you can score the full marks for this particular problem. So all of you, please study this well. And here represent the stage node as A5, B5, C5, D5. Okay. Then write the output along the all paths 0, 0, 1, 1. Then here it is 1, 1. Here it is 0, 0. B to C it is 1, 0. B to D it is 0, 1. Then D to C it is 0, 1. And D to D it is 1, 0. Then take the next two bits 0, 1 here. 0, 1 is the next two bits. Then write the branch metric associated with each branch. Here it is 1. Here it is 1. Here also 1 is the metric. And here 0, 0, 1 is the metric. 1, 0. Here both the bits are different. Therefore, 2 is the metric here. First bit different, second bit different. Then here 0, 1. Therefore, 0 is the metric here. 0, 1. So 0 is the metric. 1, 0, 2 is the metric here. This we have written associated with each branch. We are writing the branch metric. Okay. Then then we will have to write the path metric here, total path metric. So here 2 is the metric, path metric, total path metric up to this node A4. Therefore 2 plus 1, 3 here. Then another, here we have 3 up to this 3. Then 3 plus 1, 4. Then 2 plus 1, 3 here. And another branch 3 plus 1, 4 here. Then here 2 plus 2, 4 here. Here 2 plus 0, 2. Then here 2 plus 0, 2 here. Then here 2 plus 0. Then here 2 plus 2, 4. Okay, here also we cancel the path with the higher metric, that is 3 is cancelled. Here for this branch path with the path with the metric 4 is cancelled. Here path with the 4 is cancelled. Put a cross mark on that. Here this is cancelled. One more stage can be represented with that. It will be almost complete. Then only remaining is one stage. Here represent the nodes as A6, B6, C6, D6. Along this path 0, 0, 1, 1, 1, 1, 0, 0, 0, 1, 1, 0, 0, 1, 1, 0. Take the next two bits 0, 1, 0, 1 here. Then find the branch geometry here. Here it is 1, here it is 1, here also 1, here it is 1, 0, 1. Here the branch geometric is 0, 1, 0. Here it is 2, here it is 0, 1, 0 here, it is 2. Then write the path metric here. It is 3, 3 plus 1, 4 here for the above path. Then here it is 2, 2 plus 1, 3 here. Then 3 plus 1, 4 here. Then 2 plus 1, 3 here. Then here 3 plus 0, 3 here. 2 plus 2, 4 here. At D6, 3 plus 0, 3 here. Then here 2 plus 2, 4 here. Then we have two more bits here, 1, 1. Then you can draw the next stage like this. Then finally the surveyed path, we say it is as surveyed path. It is the path with lower path metric. It is in the next stage. You can see only one path will be having the having the lower metric. In problems, only one path will be with that. Here it is up to this. There are three paths with the metric 3. In the next stage, definitely, I think the only one path will be having the lower metric. Then identify if that particular path, for example, if it is this particular path arriving at C6, then we can see we can trace that path C6, B5. This we will have to trace like this: C6, B5, C6 to B5. Then this path is cancelled. Therefore, therefore A4. Then from A4, it is cancelled. Then it is C3. Then from C3, B2. To B2. From B2, it is A1 and A0. Like that, it is I have written as an example. A1, B2, B3, A4, B5, C6. We have identified that surveyed path like this. Then decoding. First A0 to A1. It is a solid line. Therefore, input bit is 0. Then next branch is here. It is 0. Then next branch in part of the surveyed path A1, B2. A1, B2. It is showing that it is a dotted line. Therefore, 1 is the input bit. Then next is B2, C3. From this B2, C3, it is a solid line. Therefore, 0 is the input bit. Then C3, A4. C3, A4. Sorry, where is this? C3, A4 here. It is. It is a solid line. Therefore, 0 is the input message bit. Then A4 to B5. A4 to B5. It is a dotted line. Therefore, 1 is the message bit. Then B5 to C6. B5 to C6. It is a solid line. Then 0 is the input message bit. In that way, we can decode the code. Okay. Hope that you have understood this particular convolutional code decoding using Viterbi algorithm.